The topic is linear dependence and independence. So let's do this example. Determine whether the set of functions 2x squared, 6x minus 3x squared, x squared plus 2x is dependent. So let's read the definition right here. The definition says a set of functions f1 of x, f2 of x, all the way to fn of x is linearly dependent if there exists some constant c1 all the way to cn, not all zeros, such that c1 times f of x plus c2 times f of 2 of x all the way to cn of fn of x is equal to 0 for every x in I, in some interval I. And independence means that, definition of the independence is right here. A function f1 of x all the way to fn of x is linearly independent on I, means if the linear combination c1 f1 of x all the way to cn fn of x is 0, then those constants, all of them has to be 0. So the only linear combination that will give us zeros for all those coefficients to be 0 for every x in the interval I. Alright, so how do we proceed? So first, what we do is we're looking for some constant. Since we have three functions, f1 of x, f2 of x, so this is your f1 of x, this is your f2 of x, and this is your f3 of x. So we're looking for three constants, c1, c2, c3. We want c1 times f1 of x plus c2 times f2 of x plus c3 times f3 of x to be 0. So if we can find three constants such that not all of them 0 that will satisfy this equation, then it's linearly dependent. So let's see, c1 times f1 of x happens to be 2x squared plus c2, f2 of x happens to be 6x minus 3x squared plus c3 times f3 happens to be x squared plus 2x, and this is equal to 0. So we want to see if we can find any constants. So the easiest, the way to do it when you have polynomial, just multiply the constant or distribute the constant. So c1 times 2x squared is 2c1x squared plus, distribute c2, you get 6c2x minus 3c2x squared. Distribute the c3 plus c3x squared plus 2c3x is equal 0. Now, next thing what we do, we always factor the x squared and then the x. So all the terms that has x squared, so it's 1, 2, and then 3. So if you factor x squared, you get 2c1 minus 3c2 plus c3, everything factor of x squared, and then factor the terms that have x, will be these two that are left, plus 6c2 plus 2c3 factor of x is equal to 0. But remember, 0 is 0x squared plus 0. So now, these two polynomials are equal, means their coefficient is equal. So 0 has to be equal this quantity, which means 2c1 minus 3c2 plus c3 is equal to 0. And then this 0 has to be equal to the coefficient of x. Well, actually, they write it plus 0 times x. So that would be 6c2 plus 2c3 is equal to 0. So if we can find any constant c1, c2, c3, for which, as long as not all of them are zeros, then it's dependent. So of course, you can pick any number here. I'll pick, I don't know, let's pick, for example, let's pick C2, just to make it easy. Let's pick C2 to be 1, for example. You can pick any number. If you pick C2 to be 1 actually. Yeah, it's fine. Let's pick C2 be equal 1, see what happened. So if we pick C2 equal 1, then I'm going to plug 1 for C2. I'm going to plug 1 here and then 1 here. So this will be 2C1 minus 3 times 1 plus C3 is equal 0. And then 6 times 1 plus 2 C3 is equal 0. So this means the top one, the bottom one, let's start with the bottom one. The bottom one right here, this is going to give us 2C3 is equal minus 6, which means C3 is equal negative 3. So we found C3. We already assumed C2 is 1. Now what else? We need to find C1. So plug C3 here. So we'll get 2C1 minus 3 times 1 plus C3, we said it's negative 3. And this is 0, which means, let me finish it here. This goes here. This means 2C1 minus 3 is minus 6 is equal 0. 2C1 is equal 6. C1 is equal 3. So we found 3 constant, not all of them 0, such that C1 times 2x squared plus C2 times second function plus C3 times third function is going to be 0. Therefore, it's dependent. So what we said, so basically what we just proved, C1, which is 3, times the first function plus C2, which is 1, times the second function plus C3, which is negative 3, times the third function. We just found that that's a 0. We can check it just to make sure. So this is my C1, this is my C2, and this is my C3. So first let me write, therefore our set is dependent. Now let's just check. 3 times 2 is 6, so this is 6x squared plus 6x minus 3x squared minus 3x squared minus 6x. Is this going to give us 0? Yes. 6x squared minus 3x squared minus 3x squared, they cancel, and then 6x minus 6x, it cancels, so it's 0. And that's it for this problem.